Our topic for today is all about minimum spanning tree using Kruskal's algorithm. The minimum spanning tree is an example of graph theory. Next is we're going to tackle the definition of terms of this subject matter. When we say spanning tree, so given a connected and undirected graph, a spanning tree of the graph is a subgraph that is a tree and connects all the vertices together. So what do we mean by connected and undirected? So connected means always keep in touch, or yung tinatawag natin sa Tagalog na hindi putol-putol. And when we say undirected graph, it is something that is unexpected. Kumbaga, hindi natin alam kung ano yung mangyayari sa graph after we solve it using spanning tree. And hence, a spanning tree does not have cycles and it cannot be disconnected. So ano naman po ang ibig sabihin ng it does not have cycles? So when it comes to dealing with spanning tree problems, dapat yung answer natin or yung resultant output would not have any cycle forms. Ibig sabihin, kapag yung current index or vertex natin is nagpo-form ng cycle, hindi natin siya pwedeng i-consider na part ng spanning tree. And of course, it cannot be disconnected. So anong ibig sabihin? Dapat daw yung spanning tree output natin is hindi putol-putol. Kasi sabi nga sa definition, connected and undirected. Okay, let's take a look at this example. We have here in the right corner the spanning tree, and in the left corner is the graph. So in the left corner, we have A, B, and C as vertices or vertex, which means it is the point opposite to and farthest from the base of a figure. And then we have the line connected in all vertices or vertex, which is called edge, which is the line where represents where it begins and end. And we have another this is what we call edge value, which determines the cost of edge distance. And in the right corner is an example of a spanning tree. So the possibilities of outputs na pwedeng mangyari sa tatlong vertex or a graph. So sabi kanina sa definition, it cannot be disconnected and it should be undirected. Kung mapapansin natin sa graph, walang cycle forms na nangyari and it is connected through its vertices or vertex. Another term in dealing with this spanning tree is finding the minimum spanning tree, in which, according to the definition, the spanning of the graph whose sum weights of edges is minimum. Anong ibig sabihin? Hahanapin daw natin yung minimal cost, in which tinutukoy dito yung total weights of edges from each vertices. For us to successfully find the minimum spanning tree, we're going to use the Kruskal's algorithm, the 3 steps for finding the minimal or minimum spanning tree. Now we have here the 3 steps of Kruskal's algorithm in dealing with minimum spanning tree. In step 1, we're going to sort all edges in non-decreasing order of their weight. So, ibig sabihin, non-decreasing means no element is less than the element before it. Or in other words, nakasort according to the cost or sizes from lowest to highest value. So, kailangan natin isort yung given problem or weights ng edges according to the sizes. So, from lowest to highest value. And then after that, we're going to proceed in step 2, which is we're going to pick the smallest edge and check if it forms a cycle with the spanning tree. So sabi dito, if the cycle is not formed, we're going to include this edge and else disregard it. So ito yung sinasabi natin kanina na bawal yung mag-form ng cycle when it comes to finding the minimum spanning tree. So kapag daw nag-form siya ng cycle, hindi natin siya ilalagay. Kapag hindi naman siya nagkaroon ng cycle form, so we're going to include this edge in the minimum spanning tree. And then in step 3, we're just going to repeat the step 2 until there are v-1 edges in the spanning tree. So what do we mean by v-1? If b is the count element, the highest index is v-1. So that means yung v-1 is the last element. So sabi dito sa step 3, uulitin lang natin yung step 2 until we come up with the last element. So yun lang yung tatlong steps ng Kruskal's algorithm in order for us to successfully find out the minimum spanning tree. Let's take a look at this example. In the graph is a total of 5 vertices or vertex represented in a circle form using vertex 0, 1, 2, 3, and 4. Kung mapapansin natin, may mga numbers na nakalagay in between the two vertex. Ito yung tinatawag natin na value or cost of the edge. And then if we're going to apply the steps of Kruskal's algorithm in step 1, we're going to sort all the values according to the sizes or yung tinatawag natin kanina na non-decreasing elements. That means isosort natin siya according to the size from lowest to highest value. Kaya kung mapapansin nyo sa table, we have 1 as the first element since siya yung pinakamababang value. At saka yung reference naman niya sa edge is vertex 2 and 3. Kung mapapansin natin sa table, it is represented by V2 and V3 respectively as reference. And then, our second element is the value of 2 since siya yung sumunod sa value na 1. And then, of course, we have the reference edge of vertex 4 and 3. At saka yung sumunod naman na number sa 2 is the value of 3 which is the reference edge of vertex 0 and 2 and so on and so forth. So ganun lang yung pag-determine ng mga values according to the sizes or yung tinatawag natin na non-decreasing elements. That is for step 1. After successfully sorted all the values, we're going to proceed in step 2 in which we are going to check if the edge line from one vertex to another forms a cycle or not. So if it forms a cycle, we're going to disregard the edge. But if not, we're going to include the line edge in the spanning tree. Okay, let's take a look at this element number 1. The value of 1 from the reference edge of vertex 2 and 3. Since this is the first element, hindi pa siya magfo-form ng cycle or hindi pa siya magko-connect sa iba pang line edge. Therefore, our first element is accepted in the spanning tree. So, belong siya sa spanning tree natin. Next element is the value of 2 in which the reference edge of vertex 4 and 3. So, i-check natin siya kung nag-form na ba siya ng cycle. Okay, our first element is from vertex 2 and 3. And then, our next element value of weight is from vertex 4 and 3. So, dalawa pa lang sila, kaya hindi pa sila nag-form ng cycle. Therefore, vertex 4 and 3 as reference edge with the value of 2 is accepted or included in the spanning tree. So that's for element number 2. Next is element number 3 with the value of 3 and reference edge of vertex 0 and 2. From vertex 2 and 3, we come up with a line from vertex 2 to vertex 4. As the third element represents the vertex 0 and 2, kapag in-interconnect natin silang tatlo, at kapag nag-form sila ng cycle, this vertex 0 and 2 will not be included in the spanning tree. And since napapansin naman natin na hindi pa sila nag-form ng cycle, therefore, vertex 0 and 2 is included in the spanning tree. That's for element number 3. Okay, this time, we're going to check if the value of 5 from reference edge of vertex 1 and 4 forms a cycle or not. Kung mapapansin natin, from vertex 0, 2, 3, and 4, nag-form sila ng line but it doesn't form a cycle. Therefore, kapag nilagay pa natin sa vertex 1 and 4 sa ating graph or spanning tree line and it doesn't form a cycle, therefore this vertex 1 and 4 is included to the spanning tree. Let's proceed to next element. The value of 7 with the reference edge of vertex 2 and 4. Kapag kinonect natin si vertex 2 and 4 sa ating spanning tree graph, kung mapapansin natin sa representation, nag-form siya ng cycles from vertex 2, 3, and 4. And therefore, this vertex 2 and 4 with the value of 7 will not be included in the spanning tree. Kasi nag-form siya ng cycle, hindi natin siya i-accept as part ng spanning tree. Next element is the value of 9 from the reference edge of vertex 1 and 2. So if we're going to include or connect the line edge of vertex 1 and 2, magkakaroon ng interconnection na cycle sa vertex 2, 3, 4, and 1. And therefore, the value of 9 with the edge reference of vertex 1 and 2 is not included in the spanning tree. Okay, now here we are in the last element. The value of 10 from the reference edge of vertex 0 and 1. Now we're going to check if we're going to include the value of 10 from the reference edge of vertex 0 and 1 to our spanning tree. Kung mapapansin natin sa graph representation, obviously naman na it forms a cycle. Kasi si vertex 0 is connected to vertex 2, vertex 2 is connected to vertex 3, vertex 3 is connected to vertex 4, vertex 4 is connected to vertex 1, and this last element is also connected to vertex 0. Therefore, hindi natin siya i-include sa ating spanning tree kasi magba-violate tayo ng rules ng minimum spanning tree. So, sabi sa rule, if it forms a cycle, disregard it. And if not, include it. So, therefore, we're not going to include the value of 10 in our spanning tree. This is our last element value. Okay, finally, we have here the final output of the given problem of 5 vertices. So, yung pinaka-final output is ganito yung itsura. Tatanggalin yung mga hindi included sa spanning tree at saka yung mga included lang yung matitira. Now, we're going to find how many edges in MST and how many total cost of MST in the spanning tree. So, in computing the edges in MST, obviously naman na may 4 na line. So, that is the edges of the vertices. And then, if we're going to compute the total cost of MST, we're just going to add up the edges value of all the spanning tree, like 3 plus 1 plus 2 plus 5 is 11. Now 11 is our minimum spanning tree total cost. So with the representation of table, yung naka-blue is yung accepted or included in the spanning tree, and yung naka-black is excluded, in which kapag nilagay natin siya sa spanning tree, magpo-form siya ng cycle, kaya hindi natin siya in-include sa spanning tree. So the essence of spanning tree is, sabi kanina sa rule, it doesn't form a cycle and it is connected to each other. Let's try another example. So this is from our page 4 of Unit 4 module. And we have here 9 vertices in total, with a representation of a circle, vertex 1, 2, 3, 4 hanggang 9. Okay, again, in finding the minimum spanning tree, we're going to use again the Kruskal's algorithm step 1, and that is to sort all the values available in vertices and edges. Okay, from edge 1 and 3 as reference, we have the value 2. Kung mapapansin natin, may 4 na pinakamababang number sa graph, which is yung number 2. Makikita natin siya sa vertex 2 and 3, vertex 7 and 8, and vertex 4 and 5. So, bakit pinagsama-sama or magkasunod-sunod yung mga values na magkapareha? Kasi sabi nga kanina, sorting it in non-decreasing order. That means, dapat sa kanilang 4 na magkaparehas na values, hindi pwedeng sumingit sa number 3 kasi from lowest to highest value yung representation ng order. So that's why prioritize yung pinakamababa kahit marami sila. And then of course, our fifth element with the value of 3 is from vertex 3 and 4, and then tatlo na naman sila, kaya pinagsama-sama sila sa magkasunod-sunod na elements para makomply yung non-decreasing order, and then so on and so forth until the last element value of 9. Next is we're going to check if the first element forms a cycle. Okay, since this is our first element, hindi pa siya magpo-form or magka-connect sa ibang vertex, kaya hindi pa siya magpo-form ng cycle. Therefore, our first element is included in the spanning tree. Next element is the value of 2, in which we're going to check if it forms a cycle. Since makikita naman natin sa representation na dalawa lang silang line na active as spanning tree, therefore the vertex 2 and 3 with the value of 2 is included in the spanning tree. Next is element number 3 from vertex 7 and 8 with the value of 2. We're going to check if it forms a cycle. So since there is no other lines interconnected to vertex 7 and 8, therefore it is included to the spanning tree. Next element is from vertex 4 and 5 with the value of 2. Kung mapapansin natin, it doesn't form any cycle. Kaya sa vertex 4 and 5 is included to the spanning tree. Let's proceed to next element, the value of 3 from edge reference vertex 3 and 4. If we're going to include this vertex 3 and 4 in our spanning tree, magtatanong naman tayo dito na, does it form a cycle or not? So since Obviously naman na hindi pa nag-form ng cycle, therefore, the vertex 3 and 4 is included to our spanning tree. Next element is from value of 3 with the reference edge of vertex 2 and 4. We're going to check if we're going to include this vertex 2 and 4 in our spanning tree. Mapapansin natin, kapag in-include natin siya sa ating spanning tree, magpo-form ng cycle si vertex 2, 3, and 4. So therefore, this vertex 2 and 4 with the value of 3 is not included to our spanning tree. Next element, again, with the value of 3 with the reference edge of vertex 6 and 8. Kung mapapansin natin, if we're going to include the vertex 6 and 8, it doesn't form any cycle. Therefore, this 2 vertex is included to our spanning tree. Next element is the value 4 from reference edge of vertex 6 and 9. We're going to check if we include this vertex 6 and 9 to our spanning tree, kung magfo-form siya ng cycle or hindi. Since hindi siya nag-form ng cycle, we're going to include this vertex 6 and 9 to our spanning tree. Next element is the value of 5 from the reference edge of vertex 1 and 2. If we're going to include this vertex 1 and 2 to our spanning tree, kung mapapansin nyo, si vertex 2 and 3 is connected already, and then vertex 3 and 1 is connected to each other, and therefore this vertex 1 and 2 is not included to our spanning tree kasi magfo-form sila ng cycle. So yun po yung reason kaya hindi included si vertex 1 and 2 sa spanning tree. Next element is the value of 5 again from the reference edge of 5 and 7. Let's check if we include this vertex 5 and 7 kung mag-form siya ng cycle to other vertices that is already connected. Since makikita naman natin na hindi pa nagpo-form ng cycle if we are going to connect the vertex 5 and 7, and therefore the vertex 5 and 7 with the value of 5 is included to our spanning tree. Next element is the value of 6 from the reference edge of 4 and 7. Let's check out if it forms a cycle or not. As you can see in the representation of graph, vertex 4 and 5 and vertex 5 and 7 are already connected. And if we connect vertex 4 and 7, magfo-form sila ng cycle. Therefore, this vertex 4 and 7 with a value of 6 is not included to our spanning tree. Next element is the value of 7 with the reference edge of vertex 2 and 5. Let's check if we include this vertex 2 and 5 to our spanning tree kung magpo-form siya ng cycle or not. Obviously, vertex 2 and 3 is connected already, and then vertex 3 and 4, also vertex 4 and 5 is connected to each other. And therefore, kapag kinonect pa natin si vertex 2 and 5, magfo-form na sila ng cycle. Therefore, the value of 7 in the vertex 2 and 5 is not included to our spanning tree. So, ganun lang yung mag-determine ng included tsaka excluded. Kapag nag-form siya ng cycle, disregard it. At kapag hindi siya nag-form ng cycle, include it to the spanning tree. Our next element is the value of 7 again from the reference edge of vertex 5 and 8. As we can notice, vertex 7 and 8 and vertex 5 and 7 is already connected to each other. And therefore, kapag kinonect natin si vertex 5 and 8, magpo-form sila ng cycle. Kaya hindi natin pwedeng i-include si vertex 5 and 8 in our spanning tree. So, excluded si vertex 5 and 8 kasi nagpo-form sila ng cycle. Next element is the value of 8 from the reference edge of vertex 5 and 6. As we can notice, vertex 5 and 7 is connected, vertex 7 and 8 is connected to each other, and vertex 6 and 8 is also connected. Kaya kapag kinonect pa natin sa vertex 5 and 6, magpo-form sila ng cycle. Therefore, the value of 8 from vertex 5 and 6 is not included to our spanning tree. Okay, let's proceed to the last element, the value of 9 from vertex 3 and 7 as reference edge. As we notice in the graph, vertex 3 and 4, vertex 4 and 5, vertex 5 and 7 is connected to each other. And if we connect the vertex 3 and 7, they can form a cycle. Therefore, we're not going to include the value of 9 from the vertex 3 and 7 to our spanning tree. As a result, after finally integrating the 3 steps of Kruskal's algorithm, we have here our final output. As an indicator, kung makikita nyo sa baba, yung naka-yellow-green na nasa table is yung mga accepted sa spanning tree. At saka yung mga naka-black naman is yung mga excluded sa spanning tree. So, tinanggal na natin yung mga excluded sa ating graph na yun kasi final result will represent the spanning tree. And then, if we're going to count the total edges in MST, we're just going to count off the edges in between the vertices. Like, vertex 1 and 3 is one edge, vertex 3 and 2 is another edge, vertex 3 and 4 is another edge, so on and so forth. And then we have a total of 8 edges in the spanning tree. And then if we're going to count the total cost of minimum spanning tree, just add all the edges value like 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 5 with a total of 23. So that is how we are going to compute or to come up with the total cost of MST and edges with, of course, using the 3 steps of Kruskal's algorithm.